Hi there! Welcome to the second part of Data Teach's YouTube series, in which we're going to do an introduction to statistics. In this video, we're going to be talking about statistical summaries and confidence intervals. Let's get started. So starting off with some statistical summaries, first off, we have the mean. The mean is the average of our data set. Essentially, the sum of all of our data divided by the number of data points that there are. Next up, we have the median. The median is the middle value of our data set when it's ordered from least to greatest. And then we have the mode. The mode is the value that appears most frequently in our data set. So let's do a quick example. What is the mean, median, and mode of the following numbers? And before I answer, I'd like you to pause the video and see if you can figure out yourself. Okay, so the mean should be 5 as you add them all up together to get 40, and since there are 8 numbers, you divide 40 by 8 to get 5 as the mean. Next up, we have the median, which should be 4.5, and since 4 and 5 lie in the middle here, we add them to get 9 and divide by 2 as it's the average, and we get 4.5. Next up, we have the mode, which is 3. 3 occurs 3 times, so it's the most frequent number, and that's why that's our mode. So why are these important? These are important as they provide us valuable insights into the characteristics and distribution of our data. They also allow us to make educated inferences and predictions. So here's a quick question to think about. How do we find the mean, median, and mode if we have a data set with hundreds or even thousands of data points? So when it comes to calculating data sets, large data sets can contain thousands or even millions of data points. Manual calculations for things like mean, median, and mode would be super impractical and also very time consuming. However, coding allows for efficient computation of these measures, making it actually possible to analyze large datasets quickly and also accurately. Moving on to confidence intervals and sampling. A confidence interval shows the range where the true population value is likely to fall, based on sampled data and a certain confidence interval. So let's do a quick example now. So suppose we're trying to discover the average height of all the high schoolers in the United States. The only way to get this true value is by going to every single high school and then measuring the height of every single student. This would take months and also a lot of plane tickets, so it's not very efficient. Luckily, there are much more efficient ways to do this. So how do you guys think that we can get an accurate representation of the average height of high schoolers in the US without measuring the height of every single student? Same thing again, before I answer, I'd like you to pause the video and see if you can figure this out. Okay, so if you answered to take a sample of the high schoolers and then making a conclusion, you would be correct. So distinguishing between a sample and a sample is a smaller group selected from the people or things we're interested in, and a population is the entire group of people or things we are interested in. We often use samples when it's impractical or impossible to collect data from the entire population. As we can see from the past slides example, it was very impractical or practically even impossible to measure the height of every single high schooler in the United States. Here's a quick question to think about. What do you guys think is the main drawback of not using the entire population of data? And there's so many answers for these. Moving on to another example. Say we conducted a study and created the statement that we are 95% confident that the true average height of all the high schoolers in the United States falls between 64 and 68 inches. The interpretation of this would be if we conducted the study 100 times, approximately 95 of the 100 confidence intervals created would contain the true population parameter. So going back to that past slides example, the main drawback of using samples to estimate a parameter such as the average height of all the high schoolers in the US is that we will never know the exact number. We can get very close, but we can never say with 100% confidence that we have the exact number. And this is where confidence intervals come in. Instead of guessing an exact number for a range, we can instead create a range for our estimate. And then we can say with a level of confidence that the true value of the population will fall within this. So for our final question, using our intuition, do we want our confidence interval to be larger, so essentially a wider range, or smaller, a narrower range? And this is something to keep in mind for the next lesson. Thanks for joining in for this lesson. See you next time.